We are picking up in 12.6 where we left off yesterday. And as we pick up here, remember we're talking about probability and decision making. So we're talking about probability and basically putting the probability and expected value together to decide, whether a situation is fair or not fair. And we talked about a couple of different games and whether they are fair or not fair. We also discussed first hour. The hardest part of this lesson is sometimes reading and understanding what they're giving you. Like what the situation is. But let's talk about Rashawn here. Rashawn offers you a game where you roll a number cube. If the roll is less than 5, you get the number of points rolled. If not, Rashawn gets the points rolled. Is the game fair or unfair? If it is unfair, which player has the advantage?
It's unfair.
Why unfair?
His name's Rashawn.
Fair enough.
Profile.
He seems a little sus.
Okay. Let's keep it on the up and up, please.
The roll of 5 is less than 5 means that Rashawn only has a 1/6 chance of getting a point, right? I think somebody has a 1/6 chance of getting a point. No.
You do.
Yeah. Yeah, you have a 1/6 chance of getting a point. And the other person has 5/6.
No. Sean has 5/6.
5/6.
Not exactly.
4. Yeah. Exactly.
Now, let's
No, it's the other way around, actually. Yeah.
Wait.
okay.
Yeah, no, I was right.
Were you?
First of all,
Yeah.
irrelevant of who's who, whether it's Rashawn or you or which one we're talking about. If the roll is less than 5, what is less than 5?
4, 3, 2, 1.
If the roll is less than 5, you get the number of points rolled, which means you get 1, 2, 3, or 4 points, yes?
Yes.
Okay. If not, Rashawn gets the points rolled. So what does Rashawn get points for?
5.
5 or 6.
He gets points
I don't know what you
if a 5 or a 6 is rolled. Now, so I'm assuming the 1/6 is because you guys were misreading the less than 5 part.
Yeah, so 2/6.
Okay. Now, here's the catch, guys. Each roll means different points. While, which way is it? Rashawn has 2 places he can roll, and I have 4 numbers I can get. How do you get points? It's not just 1 point if you get the number. It's if I roll a 1, I get 1 point. If I roll a 2, I get 2 points, 3 points, 4 points. So we have to look. This is what we're going to use expected value here because we have to look at points versus probability. Okay? Because as you're guessing, it is unfair. But which way is it unfair? Because I've got smaller point values, but I have more chances to earn points. Whereas Rashawn has higher point values, but less chances. So where does it balance out? Okay?
11.
It's 11 and 10. You add them together.
Okay, now, look at the probabilities real quick. This is basic. What's the probability of rolling a 1?
1/6.
1/6. I'm just writing these down, even though you guys know them. Probability of rolling a 2? Also 1/6. Probability of rolling a 3? So on and so forth. Probability of a 4? Probability of a 5? And probability of rolling a 6? 1/6. I know they're all repetitive. I still went ahead and wrote them all down. Now, as we think about those with expected value, if we do this from my point of view, okay, or your point of view, in other words, not Rashawn. If we roll a 1, what's our chance of rolling a 1? 1/6. And a 1 would earn me points, yes?
Yeah.
So that's a positive 1. So I'm going to say 1 times 1/6 because 1 point is one of my outcomes. I have a 1/6 chance of getting it. Plus, another of my outcomes is the 2. What's my chances of getting a 2? 1/6. So 2 times 1/6. Plus, next outcome is a 3. What's my chance of getting that? 1/6. Plus, the outcome of getting a 4 is 1/6. Plus, now, what happens when we get to 5?
It's a negative.
Okay.
Negative.
These points are no longer in my favor. These points are in
Rashawn.
Rashawn's favor. So instead of saying plus a positive 5, I'm going to say plus a
-5.
negative 5 because these points are going against me. So this is a negative 5. What's the chance of rolling a 5? 1/6. Plus, and what do we know about 6? Negative 6 because the 6 is in Rashawn's favor. And the chance of rolling a 6 is
1/6.
1/6. So I went through every outcome. If it was mine, I made it positive. If it was in favor of Rashawn, I made it negative. Multiplying them each by the probabilities. Now, the multiplying is easy if you let it be. What is 1 times a sixth?
1/6.
What's 2 times a sixth? 3 times a sixth? 3/6. And I'm not reducing these because I like my common denominator. 4 times a sixth? -5 times a sixth? -5/6. And -6 times a sixth. I'm going to say -6/6, but I agree with -1. Now, I did this, I left them all common denominator on purpose, right? 1/6 plus 2/6 plus 3/6 plus 4/6 is what? The positives are 10/6. The negatives are 11/6. So if I think about this as 10/6 plus -11/6, where are we at? -1/6. So I have an expected value of -1/6.
So it's Rashawn's favor.
Okay, so it's not fair because my expected value did not come out to be 0. Remember, 0 means in a fair situation. Because my expected value is negative, negative in this case would indicate it's in Rashawn's favor because that's where we had the negative points. Does that make sense? Okay, so game is unfair and Rashawn has the advantage. Okay, get what you need there. I know some of the problems were confusing yesterday. I don't know, I feel like Rashawn's is a little less confusing once we get into it. But I think it's a good example of, looking at the point values versus the probabilities and how they can offset each other. Okay, so we have what we need here.
See?
Okay, let's talk about some tablets. The Silicon Valley Company manufactures tablets and computers. Their tablets are covered by a warranty for 1 year. So if the tablet fails, the company replaces it. Since the failure rate of their model, Tab 5000, tablet is high, the head of production has a plan for replacing certain components inside the Tab 5000 and calling the new model the Tab 5001. If you were the head of production, would you recommend switching to selling the Tab 5001? Okay.
Yes.
Now, it's not as easy as just a simple yes or no.
It is with
Okay.
that's common sense. If you're gonna
Now,
add something, it's better
We
to
have
say
this
so.
chart. Let's look at it. Okay. The Tab 5000. Information we know about the Tab 5000. The cost to produce it is $100. The price it's selling for is $150. And this one has a 5% failure rate within the first year, which notices when their warranty is. And on that 5% failure rate, the replacement cost of the company is
$130.
$130. Okay, as opposed to the Tab 5001. Cost to produce the Tab 5001 is $105. The price they're selling it for is also $150. This one has a 1% failure rate within the first year, and the replacement cost of the company on this one is $135.
From the
Okay.
consumer point of view, we want the new model.
just because it's a new model.
Well, no, because it fails less and it's only $5 more to replace if the likelihood that it fails, which is 1%.
It goes so far, $5 more to produce, so in reality, they're only losing $10
No, because
from
you
the
get,
production
Okay.
cost.
you get the $5 from the replacement.
Let's look at the numbers officially, okay? Because I'm not necessarily disagreeing with you guys, but I want the official data to prove it, okay? So,
You can rationalize this
Think-
without math, we should count it.
no, I want the math. We're math class, I want the math. So we're gonna do the math. Okay, tab 5000. What do we know about the tab 5000?
It costs 150, or when they selling it for 150, it costs 100.
Okay, so they're selling it for 150.
They're
And
making $50.
think in terms here that we're trying to figure out, which is the better deal to sell, or do we sell one, do we sell both, whatever the case is. And so we're looking at profit here. If they sell it for 150, right? So we've got the 150. However, it costs 100 to produce. So at that point, you're at a $50 profit. What else do we have to consider here?
Replacement cost.
There is a
5% failure.
5% chance of failing, and if it fails, there's a $130 replacement cost the company has to cover because of the 1-year warranty. So what are we going to do with this 5% failure?
Multiply it by that.
Okay, so we also have to subtract off 5% of 130. 5% as a decimal, of course, is 0.05, and it's times the 130. So we're going to do the math here, and this is going to be our expected value. I'm going to call it expected profit in this scenario. You do the 150, subtract the 100, and subtract 5% of 30. 43.5, which is $43.50. Okay. Now, let's look at the tab 5001 in the same way. What do we know about the tab 5001?
You're 150 selling, and it costs 105 to make.
Okay, so starting out the same way, we're selling for 150. We have to subtract off the 105 cost to produce, and
It's 1% fail rate.
1% failure rate, and the replacement cost is $135. So there's a 1% chance you're going to pay, their company's going to have to pay the $135, right? Ouch. So we're going to subtract off 1% of 135. And we're going to get an expected profit here. So 150, take off the 105, and take off 1% of 135.
43.65.
So now we're at $43.65. Okay, the question, if you were the head of production, would you recommend switching to the tab 5001?
Yes. You get a higher profit.
Okay, so you get a higher profit. It's only 15 cents, but it is a higher profit, right? And when you sell thousands of something, that adds up. What's another reason you would recommend switching?
You have a better game because you're failing less.
Okay,
Less failure.
That-
Better device.
1% failure rate. Does that make a or 1% failure rate?
That changes
Yeah.
who's buying it. How much,
Okay.
How many people are buying it.
It's going to be easier to sell when you can advertise a 1% failure rate. But the other thing is you're going to be having to use that replacement cost less, right? And so you're going to be able to have more straight out profit and not having to replace as much. So, yes, switch to the tab 5001. Expected profit is higher and less likely to fail. I don't have much room to write this, but switch to tab 5001 since expected profit is higher and failure rate is lower. Okay. Now, this next portion continues with this information. It's just changing it up a little bit. Okay. Additional data is collected for the tab 5000 and tab 5001. Production replacement costs of the tab 5001 remain unchanged. So those right there are going to remain unchanged. In A, the production replacement cost for the tab 5000 increased by $10. Okay, production replacement cost for tab 5000 increased by $10. What would the expected profit be for the tab 5000?
You do the same thing, so change 130 for 140.
And 100 to 110.
Okay, so we're using the expected profit setup we did earlier, except this time we're going to change up two numbers. So we're finding expected profit. And in this problem, we're talking about for the tab 5000. Let's see. The selling price is still 150, isn't it? So that's still 150 minus what's the production cost become? 110 minus what's the replacement cost become? 140, which means we're subtracting off 5% of 140. Okay, so it was still selling for 150 bucks. That didn't change. It said the production and replacement cost. So production cost increased by $10. So it did cost $100 to produce. Now it's $110 to produce. The replacement cost also increased by $10. It did cost $130 to replace. Now it costs $140 to replace. Okay. Did we do the math?
Yeah, $32.
So now, by changing it up slightly, we now have an expected profit of $33. Went down quite a bit when those values raised by 10, didn't it?
Yeah.
Okay. Okay, so hold on to that information.
Lost $10.
Let's look at B.
Lost in the sauce.
The failure rate for the tab 5001. So now we're talking tab 5001, and the failure rate increased by 1%. What would the expected profit for the tab 5001 be?
You do the same thing, so multiply with 5 times 0.02.
Okay, so now we're looking at expected profit of tab 5001. If we go back to what we did earlier, expected profit of tab 5001. Is it still selling for 150?
No.
Still selling for 150. Does it still cost 105 to produce?
Yes.
So we're still subtracting 105. Does it still cost 135 to replace?
Yeah.
Yes. Does it still have a 1% failure rate?
Yeah.
No. Failure rate increased by 1%. So instead of 1%, we're going to say 2% of the 135. Okay. What's the calc there saying?
42.
Okay, 4230. Okay. As you look at this,
I didn't know how to answer because I didn't know what
As-
in relation to.
let me read the question here. As a consultant for the company, what would you recommend they do to maximize their profit? So taking in what we originally saw and then taking in what just changed, what would you recommend they do to maximize their profit? What are options here?
Raise the price for each one
Okay.
by a little, not a huge amount.
Raise the price for each one, or
Like for the 501.
I would say we could talk about raising the price for 501, because here's one thought, guys. Is it normal that the previous model and the new model cost the same?
No,
No, usually what happens when the new model comes out?
it's like $700.
Okay, it's a little bit more expensive. Okay, so
Double the price of the last one.
depends on what we're talking about here. But one way or another, could we talk about raising the price of the 5001?
Yes,
Yeah,
you should.
it would be logical based on, the fact that it is the newer version. Do we still sell the 5000?
Yeah,
Yeah.
it's an affordable version. Some people can't afford it.
Yeah, you
They're
did.
not losing money on it. They're still making money.
Okay. And I think this one could be argued either way. Okay. I totally see what you guys are saying, that they are still earning a profit on it, right? Even if our profit just went to 33, that is still a profit. And there are going to be people that might not buy it if they have to buy the new version. Okay. So I'm going to totally agree with that. On the flip side, you're in the business. Your goal is to make money for your business.
If you have the $33 one selling, they're gonna buy more of the $33 one, which means you're not gonna sell more of your $42 ones, which means you're not gonna be profiting.
That was the case then.
And here's the deal. You, as a consultant for that company, what's that consultant's job?
See what's
To get money for that company, right? While we as consumers are saying, you're still making profit, you can still sell both. This one is making less profit. And if some people are still buying it, you could argue it's taking away from
the buying of
the profit of the newer one. Again, I totally see both sides on this one. Okay, so it's a matter of how you want to argue this. The data, you could argue it both ways, but what the consultant's going to say is, forget the 5000 and raise the price on the 5001, which you can do because people are going to expect to pay a little bit more for the newer model. Okay. Not saying it's a bad thing if you want to keep selling it, but we don't think as
Yep.
mean as the business consultants, right?
Yeah, but like
So
other tech companies still sell their old stuff. That's the thing in the real world.
to an extent.
I just bought the iPhone 12 almost not even 6 months ago. And now I'm the 15.
So one thought would be discontinue the Tab 5000, and then the other thought would be to increase the selling price. Increase selling price of the 5001. Okay. And here's what I'm going to say. In a situation like this, you've got numbers. C is one of those things. Yeah, I'm kind of looking for one answer, but if you can argue and support your thoughts,
They'll do.
that one's more of somewhat of, an opinion there. Because we're not the business consultants, right? That's not our job. Okay. Got the information you need there.
See.
Okay, let's talk about Gabriella. Gabriella offers you a game where the flipper flips a coin 4 times. If it lands with heads showing 3 times, the flipper gets 4 points. Otherwise, the observer gets 1 point. Would you prefer to be the flipper or the observer? Does this say we need to do some work here?
Yeah, well, I mean, if you think about it logically, right? Is it head showing three times out of the 4, right?
Mm-hmm.
Then it's 1/4 chance, or would it be half chance each time?
It'd be a 1/16th chance of that happening.
Well, it would be like 1/2
Yeah,
times
1/16, you're right.
Okay, so let's talk about a couple of things based on the conversations that are starting. First of all, let's talk about how many outcomes there are. Okay, what are we doing here? We are flipping
4 times.
4 coins, yes? So if you're flipping 4 coins, how many options for the first coin?
Heads.
Heads or tails, which is, well, I'm not talking probability, just how many outcomes?
2.
2. How many outcomes for the second flip?
2.
2.
16.
How many outcomes for the third flip?
2.
And how many outcomes for the fourth flip?
2.
So 4 2's multiplied is
16.
the 16 outcomes. So realizing there are 16 different ways you can get various heads, tails arrangements. Okay? Now, let's talk about, okay, when does the flipper win?
When it's not 3.
The flipper wins. Let's talk about how often the, flipper wins. And the flipper wins when there are what?
3 heads.
3 heads, right? Now, so there are 16 total outcomes. And we could go through and write out those 16 total outcomes, couldn't we?
Could.
But we know some math here. We've learned this chapter. How many times out of those 16 times is the flipper going to win? In other words, how many times are there going to be 3 heads?
2/16.
More than that. Okay? Now, tell me, as we're thinking about this, does order matter? Does it matter the order of the results of these coins?
No.
No. So if order doesn't matter, what am I leading you to?
16 and 0.
Combination.
It's a combination. Okay? How many coins are we flipping? 4. What are we looking for?
Or say 3.
We're looking for
3.
3 heads. So out of 4 possible heads, we're looking for 3 heads. There's a formula. Quicker for today, though, you have a calculator, yes? 4C3 can be done on the calculator. If you don't know, make sure you learn before the test. 4C3 is
4.
4. So what that's saying is there are 4 different ways that you could end up with 3 heads as you're flipping the coins. Okay? So, let's talk probability now. What's the probability the flipper wins? Flipper could win 4 times
Out of the 16.
out of 16. And we know that 4 out of 16 is 1/4 or
45%.
25%, 0.25. I have mine in decimals or fractions. So now, if there is a 25% chance the flipper wins, what is the probability the flipper loses?
75%.
And why 75%? Okay. Could you just do it as if the flipper wins, it's 0.25, then 1 minus 0.25 is 0.75, right? Now, the flipper loses is the same as saying what?
You win.
The observer wins. Realize that's the same thing, isn't it? So whichever way you wrote that, flipper loses, observer wins. Okay. Talk expected value here, because we have to get into the points, right? Flipper flips a coin 4 times. If it lands with heads showing 3 times, the flipper gets 4 points. So when does the flipper get 4 points?
Depends on heads.
25% of the time.
Okay, 4 points. A fourth of the time or 25% of the time. Okay, that's the flipper. So one option is the flipper gets 4 points. What's the other possible outcome? The other possible outcome is the observer gets 1 point. But if we're going in respect to the flipper, that means the flipper, a point is against him, right? So what is the chance that there's a negative point against him? 0.75. Do the math. 4 times 0.25 is 1. Negative 1 times 0.75 minus 0.75. What's my expected value? 0.25. Who is that 0.25 in favor of? The flipper, because it's a positive 0.25. My flipper had the positive points up here. So, would you prefer to be the flipper or the observer? Well, if you're interested in winning, we want to be the flipper, yes? Okay. So, the flipper winning doesn't have as high of a probability, but when they do win, they earn more points. Okay, so are you learning that you can't just look at, oh, observer has a higher probability of winning. That's who I want to be. You have to consider the points with it as well. Okay. Okay. One last topic. Okay. As we go back to binomial distribution, folks, we had a binomial probability formula. And every time we use it, I keep putting it on the page, don't I? Okay, keep reminding you of it. It keeps coming back at us.
Are we going to get that on the test?
We'll talk another day about that. Ask me tomorrow, okay? Now, as we look at this example, an airport shuttle has a capacity of 6 passengers. The company takes 8 reservations for each trip because 25% of their reservations do not show up. Is this a reasonable policy? So is it reasonable that they book 2 extra people every time and that sometimes they might have to leave some people behind?
Yes.
But as long as a couple of people don't show, they can take everybody. Is that a reasonable policy?
That's what they do.
Okay. It happens in airlines, right? They overbook, and if everyone shows up, somebody gets the short end of the stick and loses their flight. Okay. Now, in order to figure this out, folks, okay, so company takes reservations for each trip because 25% what? Do not show up. Now, if there's a 25% chance of them not showing up, what's that tell me on the flip side?
75% chance.
Okay, 75% chance of showing up, right? Okay, so just gathering information here. We need to look at, is this a reasonable policy? We need to look at the probability that 7 or 8 people show up and someone gets left behind. Okay, so we're going to start with the probability of 7 people showing up. In order to do the probability of 7 people showing up, guess what? Told you there's a reason for this formula. We need to think in terms of our binomial probability formula. So we're going to do the probability of 7 people showing up. Now, we need all of our information. P of 7 means what is R? R is 7, yes? Because we're doing the probability of 7 showing up. N, how many are we picking from? 8. We're talking about 8, so N is 8. We're doing the probability of 7 showing up. What's my P? What's my probability? 25% was not showing up, 75% is showing up, so my P value is the 0.75 representing 75%, yes? Okay, so fill in the formula. probability of 7 showing up, NCR, that's going to be 8C7 times P to the R. So P is 0.75 raised to the R, which is 7, times 1 minus P. So that's going to be 1 minus 0.75. Or you could just go ahead and say 0.25 raised to the N minus R, 8 minus 7, which is 1. Okay, so if you wanted to, you could say this is 8C7 times 0.75 to the 7th times 0.25 to the 1st. Calculator does the math, right? If you haven't been practicing, you've got to practice and make sure you know what you're doing here. What are we getting on this one?
2.2669. Or technically be 267.
I have 3 decimal places, so 267. Okay, so that is the probability of 7 showing up. What else do we need to look at? Probability of 8 showing up. So the only thing that changes is now, whoops, I'm going to write this out, is my R. Everything else is the same. So this is probability of 8 showing up. And so now my R value is 8. So P of 8, NCR is now, instead of 8C7, 8C8. P to the R, instead of 0.75 to the 7, 0.75 to the 8. 1 minus 0.75 to the, instead of 8 minus 7, 8 minus 8. So 8C8 times 0.75 to the 8th times 0.25 to the 0. All that matters is the 0.75 to the 8. Okay. What are we getting here?
10%. Or 0.10.
0.100. Is that rounded or does it come up to be exactly 0.1?
It's rounded.
Okay. There's other pieces after it.
1, 1,
Yeah.
2, 9.
Okay, guys. Now, is this a reasonable policy? To discuss if this is a reasonable policy, we need to talk about probability of 7 plus the probability of 8 people showing up. Those probabilities were 0.267 plus 0.100, which is, so the probability of 7 or 8 people showing up. In other words, the probability of too many people showing up for how many people can fit in the van. 36, almost 37%. So about a third of the trips are too full. Is that a reasonable policy?
I mean, majority of the time they don't show up.
Yeah. I don't know. In my book, overbooking is just wrong. So, it just doesn't make sense to me, but I'm not in that business world mindset. Okay. Now, what I will say here is that the book actually says on this one, since about a third of the trips are over full, it's not a reasonable policy. Okay. I think it's one thing when you're looking at 10% or 26%, but as we get to a third of the trips, you could argue it's not a reasonable policy. Okay. So, probability, you can write this out however you want, that too many people show up. I'm making this, probably too many people show up is 0.367 cents. A third of the trips are over full. This is not a reasonable policy. Okay. I have one problem I didn't get to. That one problem I didn't get to is similar to what we were just doing here. It's, you know, same type idea. I can put that on school here. You can see me if you want to look at that other problem. Okay. 12.6 is available and out there in Savas. 12.5 is out there and available in Savas for those of you that have opted not to do it yet. Okay. And then with that, remember, we're going to be working towards test on Tuesday.